Hi, Intro to Algebra. Yesterday you talked a little bit about exponents, and today we're going to dive in a little bit deeper and talk about products of powers. So this is also in your textbook, and be sure you've got your notebook out to take notes. All right, a big warning here. Make sure that as we're working with exponents, you're really making sense of it. If you try to just memorize it, that tends to lead students to problems. So that's just a little warning there. All right, in each of these, we're going to expand them to make sure we understand what they actually mean. And then we're going to simplify. All right, 3 squared means 3 times 3. There's my 3 squared. And 3 to the 4th means 3 times itself 4 times. There's my 3 to the 4th. Right, so what do I have all together here? Well, if I count up how many 3's I have all together, I'll notice that I have 3 to the power of 6. And for right now, we're just going to leave it like that. We could totally write it as one number, but we're going to leave it as a power there, 3 to the 6th. All right, so negative 5 squared times negative 5 times negative 5 to the 3rd. And then altogether, if I count these up, I have negative 5 to the power of 6. So remember that this is really an exponent of 1 when we don't write it. Okay, now on this next one, I put 2 different bases because I really want you to pay attention to the fact that what happened in number 1 and 2 depended on the bases being the same. So here in number 3, 2 to the 3rd just means that I've got 2 multiplied by itself 2 times. And then I've got 7 multiplied by itself 3 times. And then 2 multiplied by itself 5 times. Okay, let's consider the 7's and the 2's separately because I cannot write this all as just one power. The 2's, how many of those do I have all together? Well, I've got 3 here and 5 here, so that's going to be 2 to the power of 8. And the 7's, I've got 3 here and 2 here, so that gives me 7 to the power of 5. I can't simplify this any further than it is right there. All right, let's do with a variable now. So altogether, I've got x to the power of 9. When we're working these problems, we might not write it out every single time, but I want you to picture it in your mind. I want you to notice some patterns here. So look at the first one. We've got 3 squared times 3 to the 4th. How did that make 3 to the 6th? Well, we kind of had to, the exponent tells us how many 3's we have multiplied all together. So notice that this is the same as 3 to the 2 plus 4. That's how we ended up with that 6, right? And with this negative 5 here, we could look back at the beginning and notice that we had a 2 as an exponent and a 1 as an exponent and a 3 as an exponent, which also gave us an exponent of 6. Our final pattern we can write with algebra here as if we've got a to the power of m and a to the power of n. We've got a to the power of m plus n. And notice that the bases are the same. So that's kind of an important thing to remind yourself. A few more examples here. So now we've got a little bit different thing going on. We've got a power raised to a power. So again, look for the patterns while we do this. So this is going to mean 3 squared times 3 squared times 3 squared times 3 squared. 4 of them because it's to the power of 4. So I want you to visualize. Here I've got 2 3's and 2 3's and 2 3's and 2 3's. How many 3's altogether? That's going to be 3 to the 8th. So I want you to think to yourself, how did the 2 and the 4 determine the 8? Where did that come from? Let's see if a similar pattern comes up here. So now I've got 4 to the 5th times 4 to the 5th times 4 to the 5th. I've got 5 4's and 5 4's and 5 4's. So altogether, I'm going to end up with 4 to the power of 15. Here's with a variable, but I'm going to have y to the 10th times y to the 10th. So here I've got 10 y's being multiplied all together, and another 10 y's being multiplied all together. So what have I got? That's going to give me y to the 20th. So what seems to be the pattern going on? So you might have noticed that 3 to the 8th really came from 3 to the 2 times 4, kind of a multiplication here. And perhaps a similar thing happened here. We've got 4 to the 5 times 3. 5 times 3 is how we get the 15. And here we've got y to the 10 times 2. So if you kind of saw that pattern, you're absolutely right. That's what's going on. And we can see that. We're going to add that to our list of pattern rules. When we've got something, a power, raised to a power, we've got this multiplication of the exponents happening. a little bit more complicated here, but really just using what we've already talked about. I'm going to write out, all right, so that gives me 3 to the third, 2 to the third. And I could write that as 27 times 8, but for right now I'm just going to leave it like that because we're looking for patterns. I could write 4x times 4x times 4x. And then if I rearrange, that's 4 to the third, x to the third. And yes, you can write that as 64x to the third. Okay, we've got one more rule or pattern to add to our list then, based on what we just did. Here's our last sort of rule or pattern for the day. When you've got a product, a times b, raised to a power m, you can do the powers kind of separately. Okay, your practice for today is based on these key ideas. And these are exactly those patterns that we just wrote down. This is from your textbook. So you can write it as it is from the textbook or as we did in our notes already. Here's your practice. Notice that not all the problems are listed, just the problems that I show on the screen here. It's on page 720 in your textbook if you want to look there. So go ahead and do these problems either from the screen or from your textbook, and then make sure to check your answers.